Good afternoon, everyone, and welcome to our 2 days webinar, Electrode Design with Interfaces to CAM, CAQ, and EDM.
Hello. I thought it would be more interesting if we have some kind of example. So imagine a company called Better and Worthy Manufacturing Limited, short B&W, which is facing a number of challenges in manufacturing. So the company has a problem with data consistency and standardization because the data is too often carried from A to B, and also the designers developed too much creativity to solving design tasks, and this should be counteracted by more standardization in the electrode design process. As a second point, of course, you would like to avoid errors, which means especially the time-consuming and error-prone manual programming of EDM machines. An additional target would be to work faster, increase productivity without loss of quality. And reusability, which means you would like to reuse existing designs and maybe also use some kind of standards. So how to achieve this? The fix is in this case that B&W is already using Creo Parametric 4, 6, 7, or 8 and wants to use SMARTElectrode as additional software. In the case of the workflows, a solution for usage of external data and also a workflow for usage of standard electrodes has to be found. In the CAM department, they have for in-house milling, they use Creo NC and they use step export if they have to give the data outside for manufacturing. In the EDM area, they have Zimmer and Crime and use Alpha Moduli, the software for the whole data management. And for the computer-aided quality measuring, they have maybe a size CMM with Calypso or something from Usoft or whatever. The idea is to use the Zimmer and Crime Alpha Moduli interface as the main point to pass the data to the subsequent steps of the process. So at first, they would like to start with the positions, then maybe adding blank sizes, technology parameters, PDF and step export, measuring programs, points, and maybe also links to NC programs. So what is the current state? The introduction of SMARTElectrode is completed. So the customer has a list of blank sizes he used. He has a specific placement rule for the electrode base. In this case, the height of the solid contour and the base height is rounded to match the complete length of the template. They also have some kind of drawing templates, but they may be incomplete by now. Templates for Creo NC, and the interface is activated but not completely customized at this stage. So some additional information about the interfaces to EDM. So currently we are supporting the old RG Vision control and also the newer AC form HMI and also the Charmil DP control. So this is all from one big company. And we also have the Exaron Exobrock, Multibrock from Ingersoll, and Sodic and Makino are currently using a neutral format called EPX and Zimmer and Crime Alpha Moduli, which will be part of the presentation. So the interfaces to EDM are an additional license option for some years now, And usually there's additional customization necessary to meet the customer setup. So they can normally not used out of the box. There will be the need for additional customization normally. So let's come back to our example customer. And as a first part, they have to solve the question how to get imported data or externally created electrodes working in SMARTElectrode. So there's a comment for importing electrodes with formats step, IGES, or as a Creo part file. And the work steps are at first you have to select some references. After that, you have to set the end position, and finally you can use the whole parameter set for technology and most of the comments inside SMARTElectrode. But to show this, I have prepared video. So there's the import command, and I have a prepared step file to import. And when the model is inserted in a new part file with a correct new name for the assembly, I have to select the references, base top, the free face, and a reference surface for the C angle. After that, the part is added to the assembly, and the final end position has to be determined or set. So this can be done by using normal Creo assembly constraints or using the move user interface. And now I'm using move from point to point to place this electrode model. So. Okay, so this is finished so far. And so now this electrode model, even if it doesn't contain any features known by SMARTElectrode, can now be processed in most of the subsequent steps. Similar is the workflow for a standard electrode. So this means you have some prepared electrodes, including maybe a manufacturing assembly and maybe also already including a drawing. And then you can copy this whole data set with a new name into your electrode assembly, and it won't be changed by SMARTElectrode in any way. It's just copying the data. The only thing that is a mandatory requirement is you need a coordinate system with the name defined in the electrode options. And after that, again, all the subsequent functionalities should be available for this. So this is hidden in the copy overflow, copy template. Then you can go to your library. First, I'm selecting an incomplete model without a correctly named coordinate system. And the second step, I'm going to select a correct electrode model, including all the stuff I need. It gets a new name and will be copied into your working directory with your name, and is then available for setting the final position and also maybe add positions and add the parameters. So this electrode is rotated around the assembly origin. And now we can see that we can use the normal parameter user interface for this, and we can also open the check user interface and run effective burn phase analysis. So this solves, as a second part, the two questions for the workflows that have to be invented for the customer. And next step, how to integrate manufacturing templates. There are two main points. So customers working with Creo NC can implement or add their own templates for Creo NC. Customers doing the NC programming in a third-party software, or maybe have to deliver the parts for the external manufacturing, use a data backup for transfer. So normally a neutral format like STEP or IGES, and the reference coordinate system can be set in the export options. The templates for Creo NC should be derived from our examples. So we have 3 default manufacturing assemblies. There could be any number of templates, so for different milling machines or different use cases. And normally the templates are independent from the Electrode templates, so they should fit all of the available Electrode templates. So this is hidden behind the manufacturing UI, and just by selecting or double-click, you can select the template using. So we have the 3-axis, an empty one, and one for module works. And if you pick create, the assemblies are copied to a new name, the reference models are exchanged, and rig pieces created. So I'm now opening one of the manufacturing assemblies. As you can see, there are still some failed features, but this is just to show that this is not a real problem, because you can fix this by reroute the references. And I'll wait till this is finished. You can even integrate more milling sequences than you need in the end. So you can delete everything you don't need in this specific electrode, but there could be more milling sequences inside your templates. So even if you don't really need them for this case. Okay, let's come to the drawing output. So the creation of drawings is available for electrodes originally created in the assembly, imported on also standard electrodes, but of course, not all of the automatically created data like dimensions and views may be available for imports and standard electrodes. And also all the content of the drawings depends on the options set in your configuration. So let's have a short look on the drawing creation. Sorry, I skipped it accidentally. So here we are. So this is one big assembly drawing, including a bill of materials, a workpiece drawing sheet, electrode part drawing as next sheet, and positioning sheets, and so on. There's one specific point something I would like to point out is that the order number column is still empty. This is because this should be a custom parameter created when the electrode blank is added. So this is also the reason why we have here the parameter order number must still be added as a comment. So this will be done in one of the next steps. And we have also the first state of the data output for alpha moduli. Again, this should work with limitations for original electrodes, imported electrodes, and standards. And the specific export or interface also includes output of the models as step and drawings as PDF. So when activated, the data will be written to an XML file, and also the drawing has to be opened to save the drawing sheets as PDF. And then we'll have a look at the result. So we have the main folder on the left side with the XML file, and the PDF is opened here. So you can see SMARTElectrode saves the specific drawings sheets from the main drawing to distinct PDF files, and we have the step files of the electrodes, and now I have a short look on our XML file. So this writes the information electrode by electrode and writes also all the positions. So this is okay as a first result, but there are still some of the measure information missing. So the measuring C point is the main reference, and it's at the moment created by SMARTElectrode in a default way, but the customer maybe wants a specific position for this datum point. So this datum point will be shown here. So this is actually here on the small offset created from the side, and this has to be customized in the template. So this datum point was created by SMARTElectrode during the export, but now should be integrated in the base group. And also we would like to have a small C reference surface for milling. So we don't need to mill the whole free face. Okay, so customization of templates. There's a new functionality in SMARTElectrode, so you can open existing templates, add additional features you need, and then let the software save the templates data file and the UDF. And then you can adjust the values, add sizes to the data file, and then you publish the template by copying into your configuration. And in this specific case, in our example, I will have to recreate the base in the existing electrode models to make sure I use the new version of it. So in the first video, the customization of the template is done. So this is a prepared one. So this already includes the new datum point and the reference surface. And also the position or the dimension have specific or custom names, because SMARTElectrode is going to create a column in the data file for each custom named symbol. So if you want to control a dimension by SMARTElectrode inside the data file, it needs a specific name. Beginning with SEEDM base will be saved to the user-defined feature. So we are changing to the SMARTElectrode ribbon, open assembly, and save custom base. And then you will get a message if it was successful or not. And then data file and UDF can be copied to your personal or custom configuration after adjusting this. So we now have the prepared data file on the left side. So this shows all the values used during creation of the electrode base and also some internally used values and the dimensions. And now we would like to add also the parameter order numbers, so we can create string, double, or integer parameters. And now I'm just adding this as additional column to the data file, and then this parameter should automatically be set when the base is added to an electrode model. So this is saved, and now we still have to publish this to the configuration. So data file and group file, and this is copied in my configuration. This is done, and then in the next step, I can recreate this. So let's come to the assembly. I'm going to activate the first electrode model and delete the base created at first. Nothing else to do here, and you can see it's the updated group feature with the reference point and the surface. So this is also done for the next 2 electrodes, but this is always the same workflow. So let's come to another new functionality before we have another look into the data output. We have a user interface to add measuring points, and this has been enhanced to also allow measuring points for workpieces. There's some kind of verification functionality, and these points can also be modified in the user interface now. So this is a new functionality that should be come with the next release, but it would be nice to have some testers at first, and to share the measuring points information. This can be saved from the user interface in text files or integrated in a step export, or also with these points can be part of the data written by an interface. So at first, let's have a look how this works. So I'm activating one of the electrode models and open the CNM user interface, and then points can be added just by activating add. The points are created at pick position. That's okay. Then I have to confirm that. If I now press the verification button, spheres with the probe diameter will be placed in our model, and also would show if there is some kind of interference with the contour. We can highlight it, and we can also change the value. So if it's possible to be reached within the software boundaries. We're also moving another point, and we are pressing the verification button again. If you hit OK, then the spheres will be removed from the model again, and only the datum points are still inside the electrode model. And now we are going to also add some CMM points to our workpiece. And again, we can place the CMM points on pick position of the mouse. And now what happens if we have bad placement of the points? The spheres are created, and you can directly see that the probe diameter interferes here. And then you can try to change the values or delete and add new points. So again, it's still showing the option to save the points to a text file. So at the moment, the format for the text file is the same as the columns in the user interface, but it could also look different without the IDs, the sequence number, without the X, Y, Z, and all the other stuff. Okay, let's bring all of this together. So maybe at first we have a look into the output, what's happening now after incorporating the custom template, and after also adding measuring points, what's happening to the data output here. So at first, a look in our PDF export. If we have a look on the second page, we can see the order number is now set as additional parameter. So the parameter was created when the blank was added again. Content of the step export of the electrode model. So you can see it includes the surface colors, and also it includes the measuring datum points, but only these datum points. So there are no additional or design datum points included. Those are hidden on layer. The content of the XML, so this is the link to the PDF file. We can add the blank size. We have the workpiece material and the electrode material, electrode coordinate system position, type of program, type of blank, size of measuring frame is in this case. And we have the updated position of our reference point for the automatic measuring. So we have some technology data. Oh, no, at first it's the link to the step file. And we have some technology data, undersize quantities. Here also listed the measuring points based on the coordinate system set in the export options. And now also we're going to import the workpiece step file. And you can see also the measuring points are added as datum points to the step file and can be imported again. So this should normally be possible to read the data in your software at the CMM. Okay, as a summary, what learned B&W Manufacturing Limited, they could meet all the requirements for CAD and CAQ. They had the best success with doing the introductions step by step. So normally it's not working to try to bring all of this together at once. And one third point is it's extremely important that all parties are talking to each other. So the customer, the software provider, and the machine supplier, because without coordination or discussions, in the end, the export and all the integration of all the different steps won't work. So that's for the example. I have a short outlook, what should be the main topic for the next main releases, or what should be the main topic for the next few months. So I would like to introduce some kind of geometry comparison, which means you can add different versions of your workpiece to your electrode assembly and check the differences. You can maybe propagate working areas and then check if all of these areas are covered by electrodes, and also adding semi-finished work pieces to your assembly so that you can take a partly finished model from Creo NC or any CAM software and load it to your electrode assembly to see where you still have to manufacture with electrodes. But the last point is a little bit more complicated because those models are normally only tessellated data, and it will be complicated to do the comparison on tessellated data in that case. And second point is because in the past few months, I got more requests to also create electrodes, including the burn gap as a designed feature. But this will also need a detailed planning if the offset should be added to the electrode itself, or if the offset should be added to some kind of reference model, if there should be a usage of a family table or not. So all of this is unclear by now and still has to be checked. But if you have any information for me according to these points, I will be happy to get this from you. Okay, so I'd like to say thank you for the interest and the time. And I would like to hand over the presentation back to Christian. Thank you.
All right. Thank you, Florian. Now I would like to thank you for your attention and wish you all a pleasant day. Goodbye.